Good morning to everyone. Last video we have discussed about the what are the different types of solving methods available in finite element equations, and then we have discussed about the what are the different types of primary unknowns. Based on the primary unknowns, what are the different types of secondary unknowns we can able to find, and then we can find the results will be interpreted in the graphic form of graphical manner. Then we have seen about the what are the different types of finite element solvers available to solve the structural or non-structural problems. Those are the things we have discussed in the previous video. So in this video we are going to discuss about the weighted residual method. This will be a powerful approximate procedure applicable to solve several problems. So the weighted residual method is one of the numerical methods, but it will be the solving procedure will be differ from the normal conventional finite element method. So this also will be one of the numerical methods. The solution will be provided based on the approximate method for varying the parameters. So it will be solved for any type of problems, structural or non-structural problems. Here the problem will be defined in an equation manner. So that will be it mainly suitable for non-structural problem. The differential equation of phenomena can be easily formatted. So here the mainly suitable for non-structural problems. Here the object will be provided in the form of equations that will be called as an physical phenomena, and then the limit will be given as an boundary conditions. So what is the starting limit and what is the ending limit, that will be given as an boundary conditions, and then the working parameter will be given as an physical phenomena, sorry, trial function. Based on this we want to solve the problem by using a different approach in these weighted residual approaches. So the approaches are, so first one is an point collocation method, second one is an subdomain collocation method, third one is an least square method, fourth one is an Galerkin's method. So these are the different types of methods to solve the weighted residual problems. By using this method we can find the unknown values. That value will be interpreted into an our trial function. So that is the final transformation of that particular component. Then we going to see about one example problem. Here the following differential equation is available for an physical phenomena. So this is the physical phenomena of the particular objects. So d square y by dx square plus 50 equal to 0. So that will be a physical phenomena of that particular components. That will be given in the form of equation. Then 0 greater than or equal to x or greater than or equal to 50. That will be an boundary conditions. So that object will be located from the x direction. The starting point will be an 10, sorry 0, and then ending point will be an 10. In this the working parameters that is called as a trial function is y equal to a1x into 10 minus x. So this is the trial function that will be called as an parameter of variables. So that is an a1. Then they will give it as an boundary conditions of y of 0 equal to 0 and then y of 10 equal to 10. So this is the problem. They given for a physical structure and then boundary conditions and then variable of the trial function. In this we want to find the variable of a1 value. So that will be given as find the value of parameter of a1 by the following methods. So first one is a point collocation method, second one is a subdomain collocation method, third one is a least square method, and then fourth one is in Galerkin's method. So by using of these four methods for that physical phenomena, we applying the trial function in the boundary limit of 0 to 10 for each conditions. We want to find the a1 value. So that is the variable of particular locations for that particular objects. So this is the solving method of weighted residual problem. So these four methods will comes under the weighted residual method. So thank you for watching this video. We'll see you in next video.